All right, welcome back. So we're going to begin RBC, which, as you recall, is going to have the following structure. We're going to have a household. We're going to have a household that is going to supply capital K and labor L to a firm. Okay? And the firm, this is my little factory here. The firm is going to demand these two things. They're going to use it to produce a single output, Y, which the household will then consume. They will consume it and they will invest it. So this is our whole economy. There's, again, two agents, household and firm. There's a single production good, Y, which is used both for capital and for investment. Okay, so one good has two purposes. The household chooses quantities of Y to demand for those two purposes. And then it provides labor and it provides capital to the firm to produce those. So you see it's a closed system. There's no waste, so nothing is lost. Every single period we have, everything adds up. You know, YT equals CT plus IT is always true in this model. Okay. And the objective is to find, given the utility function of the household, and given the production function of the firm, to find supply and demand curves for K, L, and Y. Okay, and once we have those supply and demand curves, the intersection of those curves is going to describe the optimum conditions for the economy. So the solution, so what is the solution for the RBC model? This is an important question to be able to answer. What is the solution? What is the solution? The solution is a system of equations, a system of K optimality conditions. So we have K variables, prices, shocks, quantities. There's going to be K of them. And we're going to get K optimality conditions, and it's going to totally describe the equilibrium point of the system at every time that describe the equilibrium of the economy at all times. So even if the model is not in the steady state, the model is in equilibrium in the sense that everything adds up. Y is going to be equal to CT plus IT. The supply and demand curves are going to cross. That's always going to be true in our model. This is the GE. This is the GE in DSGE. Okay, so we're always going to be in equilibrium, but we're not always going to be in the steady state. They're not the same thing. And this K here is a number, okay? This is not the same as this K. It's just I'm saying there's K equations. There's K variables. It's going to be Y, C, I, L, and WR, lambda 7, utility 8, total cost 9, something like that. But there's going to be prices. There's going to be economic quantities. So you're going to find this. Where does the system of equations come from? The system of equation comes from the first order conditions. So they come from three sources. Source number one is the FOCs of the agent's problem, problems. Okay. They come from number two. They come from the how to write this? I want to say budget constraints, but it's not right. They come from the constraints on the optimization problems. Okay, so for example, the budget constraint in the household's case, or the production function. In the firm's case, right? The production function shows up. Oh, I covered my face there a little bit, I'm sorry. Okay, so they come from the constraints, they come from the FOC, and then they also come from the laws of motion. Okay, the laws of motion are sort of exogenously given to us as descriptions of how the state variables move. So the laws of motion. Law of motion of capital, law of motion of technology. So you're going to put these three things together. You're going to gather up the FOC, you're going to gather up the constraints, and you're going to gather up the laws of motion, and then you're going to stack them into a list, and that's your answer. You draw a box around that. So in this case, we're going to get 7 or 9 equations. I think it's 9. And we'll talk about them as we get them. So what do you draw a box around? You draw a box around any of these things. Okay, you draw a box around all of your FOCs, you draw a box around your constraints, you draw a box around your laws of motion. Okay, I said we were going to start, but I guess this is sort of a secondary preamble to beginning. So in the next video, we will actually look at the households problem, which I said here. I guess the topic of the video is wrong. This should just be the structure of the problem. Okay. So this is the structure of the problem. In the next video, we'll actually look at solving the households problem. So I'll see you there.